All right, this video is going to cover Module 2, Homework 5 notes. We're talking about exponents and scientific notation. Exponents are super helpful because instead of writing something over and over and over, we can use an exponent to show that. And we can write repeated factors in a more condensed form. So a coefficient is the number in front of the exponential term, not raised to a power, little definitions. Base is the number that's being repeated, and the exponent is the number of times it's being repeated. So for example, if we have 2x to the fourth power, 2x to the fourth power. So let me get out my markers here. This exponent of 4 tells us how many times it's being repeated, so that's our exponent. But this exponent is only applied to whatever's directly underneath it. So it's only applied to the x. So there's 1, 2, and then it's x repeated 4 times. So if I were to rewrite this out, it would be like 2 times x times x times x times x. So that 4 is only applied to whatever's directly underneath it. So this number out front, that 2, that's going to be my coefficient. The x is the number that's being repeated. That's going to be our base. And then this exponent of 4 tells us how many times that base is being repeated. So super important that 4, the exponent only applies to whatever directly is underneath it. So if you need parentheses to kind of help keep that, go for it. So let's look at some examples. Let me try to focus it a little bit. There we go. So if we have 2x cubed, just like we talked about up here, that cubed is only applied to whatever's directly underneath it. So it's only applied to the x. So it'd be like 2 times x times x times x. So 2 would be the coefficient. Our base would be x. And then our exponent would be 3. Likewise, if we have 5 squared, that means it's going to be that 2 is our exponent applied to whatever's directly underneath it. So it'd be like 5 times 5, which is in fact 25. But so for our coefficient is the number out front. Our coefficient is a number out front. There's not really a number out front here. So this is the same thing as saying the 1 times 5 squared. So our coefficient would be 1. The base is the number that's being repeated. So our base would be 5. 5 is being repeated. And our exponent is the number of times that base is being repeated. So our exponent would be 2. Here's where it gets super important, talking about coefficients and bases and exponents and all that stuff. We have -5 to the fourth power. Remember that 4 is only applied to whatever's directly underneath it. So it's only applied to the 5, not to the negative. So this is the same thing as saying -1, one time, times 5, times 5, times 5, times 5. So in our calculator, -1 times 5 times 5 times 5 times 5, we're putting this into your calculator just like it gave it to you. So negatives, we're going to use this negative down here. 5 to the power of 4, we have -625. So here our coefficient is the number out front, which would be -1. Our base is the number that's being repeated, so our base in this case is 5. And our exponent is what's being repeated, which would be 4. Versus, now this looks super similar to this one down here. So -5 to the fourth power. Parentheses group things together. So parentheses are grouping the 5 and the negative together as one thing. So this 4 is applied to whatever's underneath it. It's applied to the negative and the 5 because the parentheses group it together. So this would be -5 4 times. So -5 times -5 times -5 times -5. Which if I put this into my calculator exactly like they gave it to me, so in parentheses, which are right here, so parentheses -5 to the power, notice I did this, but I didn't really mention it. This caret button, it's like an arrow, it's called a caret button, brings us to the power. That's our exponent. So to the power of 4 gives us +625. So if you notice, these are two very similar situations, but they give us very different answers. So here, our coefficient is the number out front. There's really not a number out front, so we can say it's 1, positive 1. Our base is the number that's being repeated. In this case, our base is going to be negative 5, and our exponent will give us positive 4. All right, so that's super important topic that we're talking about. So let's continue to talk more about exponents on the next page. All right, so multiplying, we're talking multiplying, we're going to talk about it all. So multiplying exponential expressions, which is called the product rule. So here's our rule. X to the n power times x to the m power means x to the n plus m. So notice same base, they both have an x, are multiplying the same bases. That means we're going to add the exponents. So when you multiply two exponential expressions with the same base together, we're going to add the exponents. So let's look at some examples. W to the p power times w to the r power. They're both base w, so they're like terms. So combining into the same base w, we are going to use our product rule. We're going to add our exponents. So p plus r. Done. That's it. We combine our like terms using our product rule. Same thing for the next one. Simplify the following. 3 to the 4th times 3 to the 5th. They're both base 3. So I can combine it together in the same base 3. We can add our exponents. So 3 to the power of 4 plus 5. So 3 to the power of 4 plus 5 would give us 9. So 3 to the 9th power, which if you want to write it out as 3 to the 9th power, would give us 19,683. Either way is fine. We're just kind of talking about the rules here, so there's not going to be a question just like this on the homework. We're just kind of talking about it, and we're going to put it all together on the homework. So I want to talk about why this works, though. So here, if we have 3 to the 4th, that means 3 to the 4th means 3 times 3 times 3 times 3. So 3, 1, 2, 3, 4 times 3 to the 5th, which is 1, 2, 3, 4, 5 3s. So 3 times 3 times 3 times 3 times 3. So we're just writing it out. 3 to the 4th times 3 to the 5th. They're all 3s, so we can combine them together. Now, how many 3s are there total? 1, 2, 3, 4, 5, 6, 7, 8, 9. So now there's 9 3s total. So that's what gives us 3 to the 9th power. So that's what's going on behind the scenes. That's why it works. A lot of times, if you understand why it works, it's easier to remember it. So no, you can only combine like terms, meaning they have to have the same base. So we have 3 to the 4th times 2 to the 5th. They're not like terms, so I can't combine it. We have 3s and we have 2s. It would be like 1, 3 times 3. Oops. It would be like 3 times 3 times 3 times 3 times 2 times 2 times 2 times 2 times 2. So there's 1, 2, 3, 4 2s, 4 3s, 1, 2, 3, 4, 5 2s. You still have just 4 3s and 5 2s. They're not like terms. I can't combine it, so you just leave it. They're not like terms, so it cannot be simplified. So we just leave it as 3/4 times 2/5. We just leave it just like that. All right, so that is multiplying using the product rule. Next, let's divide using the quotient rule. So this time we have x to the n divided by x to the m. Notice they're both base x's, so they're like terms, and we can combine it together with the same base x by subtracting our exponents, n minus m. So when you're dividing two exponential expressions that have the same base, you can subtract the exponent in the denominator from the exponent in the numerator. Let's look at an example. If we have, to simplify the expression completely, z to the 18th divided by z to the 8th. They're both base z, so they're being divided, so I can combine it into the same base z by subtracting the exponents. So z to the power of 18 minus 8. 18 minus 8 would give us 10, so our answer would be z to the 10th power. Same thing for the next one. Simplify the expression 2 to the 8th divided by 2 cubed. They're both base 2, so we can simplify by writing it as the same base 2 and subtracting the exponents. So 2 to the power of 8 minus 3, 8 minus 3 would be 5. This would give us 2 to the 5th power. And if you want to go ahead and simplify it further, either way doesn't really matter. 2 to the 5th power would give us 32. Just like in the previous problem, let's see what's going on behind the scenes so you can understand it better. So if we have 2 to the 8th divided by 2 cubed, that would give us 2 times 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 2. So 1, 2, 3, 4, 5, 6, 7, 8 2's divided by 2 times 2 times 2. So divided by 3 2's. So now if we're dividing, a different color. 2 divided by 2 cancels out, goes to 1. 2 divided by 2 cancels out, goes to 1. 2 divided by 2 cancels out, goes to 1. So we are just left over with these and 2's up top. So 1, 2, 3, 4, 5 2's. We're just left over with 2 to the 5th power. So that's what's happening behind the scenes there. That's why you subtract your exponents. You're taking those away. So let's compare the previous examples to the ones below to remember the exponents happen before subtraction order of operations. So if we had to simplify 3 to the 6th power minus 3 to the 4th power. Remember, you're simplifying. Remember order of operations? Let me go back to that page. Real quick, let me find it for us. Here. So order of operations, whenever you simplify, you're going to go down the list. So first you're going to start with parentheses. There's no parentheses here. Next you're going to do exponents. So we're going to do our exponents now. All right, so going to our exponents. So 3 to the 6th minus 3 to the 4th. So let's do our exponents first. So our calculator, 3 to the 6th power would give us 729. Minus 3 to the 4th power, again using our caret button for our exponent, would give us 81. And then going back to order of operations, we did exponents. There's no multiplying, there's no dividing. Now we're going to add and subtract. So 729 minus 81, which would give us 648. 648. So even though it kind of looks like these up here, this is whenever you're multiplying. Whenever you're multiplying two exponential expressions, you're going to keep the same base, add the exponents. Whenever you're dividing exponential expressions, you're going to keep the same base, you're going to subtract the exponents. Here we are subtracting two exponential expressions. So you're going to do the exponential expression, do the exponents, and then subtract. All right, let's keep rolling. Next page. Now we're talking about power to a power, so the power rule. So x to the power of n to the power of n. So x to the n to the m, a power to a power. That means we are going to multiply our exponents. So x to the power of n times m. So the power of an exponential expression raised to a power is the product. Remember, product means multiply of the exponents. Product means multiply. So we're going to multiply the exponents. So simplify the expression completely. V to the 7th to the 5th. So power to a power, that means we're going to multiply our exponents. So v to the power of 7 times 5, which would give us v to the power of 35. 7 times 5 gives us 35. Done. Next one, simplify the expression 3 to the 5th squared. So let's see what's going on behind the scenes, just like we did on the previous one. We know we're going to multiply the exponents, but let's just multiply the exponents. So 3 to the power of 5 times 2, which would give us 3 to the power of 10. But like I was talking about, we know the answer is going to be 3 to the power of 10, but let's see what's going on behind the scenes so that way if we understand it, hopefully we can remember it better. So if we have 3 to the 5th squared, That means we have 3 to the 5th twice. We have 3 to the 5th times 3 to the 5th. So let's see here. 3 to the 5th is 3 times 3 times 3 times 3 times 3. 3 to the 5th, 1, 2, 3, 4, 5 threes, times another 3 to the 5th. So 3 times 3 times 3 times 3 times 3. So 1, 2, 3, 4, 5 threes. So together I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 threes. So together we have a 3 to the 10th. So it's kind of what's going on behind the scenes. So if you see it, hopefully you understand it better, the rule, and then hopefully you're able to apply it easier. This is why I don't teach English. This is why I'm able to apply it more easily. Don't judge me. All right, so next example, compare the power rule to the product rule and simplify. All right, so the product rule, remember, a power to a power, so we multiply. The product rule on the previous page, wherever we had an exponential expression times exponential expression, they had their own base, so then we added the exponents. So here we have 2 to the 4th times 2 cubed. They had their own base, so that means we're going to add the exponents. So 2 to the 4 times 4 plus 3 equals 2 to the 7th. So we're going to add our exponents. Versus, let's go ahead and do this here. So versus 2 to the 4th cubed. 2 to the 4th cubed. Now I have one base 2, a power to a power. Here's where you multiply 2 to the power of 4 times 3. So this would give you 2 to the 12th. So here's where you multiply exponents. So you can kind of see back to back. Whenever they have their own base and you're multiplying two exponential expressions, that means you're going to add the exponents. Whenever you have one base and you have a power to a power, that's whenever you're going to multiply those exponents. So those are those two back to back. Okay. So next, this is my favorite thing of this whole class, the zero exponent rule. So it's saying x to the 0 power or anything to the 0 power is 1. So when you raise almost anything to the 0 power, you get 1. So, and I'll talk about that word almost in a second. So simplifying, z to the 0 power. Z to the 0 power is just 1. Note, by the way, z can't be 0 here. You can't have 0 to the 0 power. So z cannot be 0. If we have 5 cubed divided by 5 cubed, okay, so now we need to take a step further. We're dividing two exponential expressions. That means we're going to subtract the exponents. So 5 to the power of 3 minus 3, which would give us 5 to the power of 0. Anything to the 0 power is 1, so 5 to the 0 power is 1. So here we are going to subtract our exponents. Like everything else, let's see what's going on behind the scenes. That way we can hopefully understand it better. If we have 5 cubed divided by 5 cubed, that means up top we have 5 times 5 times 5 divided by 5 cubed, so another 5 times 5 times 5. So 5 divided by 5 goes to 1. 5 divided by 5 goes to 1. 5 divided by 5 goes to 1. So essentially I have 1 times 1 times 1, which is just 1. So that's why we get 1 as our answer. Everything cancels out. Likewise, simplify the following expression completely. 2w plus 2 to the 0 power. Well, anything to the 0 power is 1. So because it's to the 0 power, it's just 1. That's it. Remember I said almost anything? Well, no, sorry here. Let's talk about this backwards. So simplify 0 cubed. So here I have 0 times 0 times 0. I don't have 0 as the exponent. I have 0 as the base. So 0 times 0 times 0 would just give me 0. So so I just wanted to show those side by side because people get that confused. They see 0 and they automatically go to 1. All right, let's talk about another one on the next page. Negative exponents. So if we have a to the power of negative n, that means 1 over a to the n power. So notice our exponent was negative. It came to the bottom of the fraction and became positive. So make exponents positive by flipping that term across the fraction bar, or its reciprocal. You flip it over. All right, so let's simplify. X to the negative 4th power. So just like up here, we have a negative exponent. So it's going to flip and go to the bottom of our fraction and become positive. So x to the 4th power is on the bottom. Notice becomes positive 4. And then there's nothing up top. We need to write 1 up top to have a placeholder. So I have 1 over x to the 4th power. Why I wrote that so large, I don't know, but whatever. Here, what if I had the negative exponent on the bottom? Notice it flips across the fraction bar. So if I have 2 over x to the negative 3 power, that negative exponent means it's going to flip across the fraction bar. Here it's on top, so it flips to the bottom. Here it's on the bottom, so it's going to flip to the top. So that 2, nothing's happening to the 2, so the 2 just stays there by itself, hangs out. And that x cubed is going to flip across the fraction bar, meaning it's going to go to the top and become positive. Now there's nothing on the bottom of a fraction anymore, so the fraction goes away. We're just left with 2x cubed. So if it's on the top, it goes down to the bottom. If it's on the bottom, it flips up to the top. And if it helps you to write 2 times x cubed, and then there's nothing on the bottom, so write over 1. Well, anything over 1 is just 2x cubed. So that's negative exponents. One more rule before we put it all together. So the expanded power rule. So if we have a times x all over b times y all to the nth power, it's saying we can take that nth power and distribute it to every single term. So a to the nth times x to the nth all over b to the nth times y to the nth. So when you have a product or a quotient, remember product means multiply. Quotient means divide. Raised to a power, you can apply the exponent to each factor. So apply it to each term. So let's see, complete this expression. C times W, so we're multiplying. So that way we can apply it to each factor. So C times W to the H power. So that means C has the H power, and W is going to have the H power. So C to the H power, W to the H power. These are not like terms, so I cannot combine it further. Done. Next, simplify the expression. 2x to the 4th divided by 5 to the 7th. We are multiplying and dividing only here, so that means I can take that 7th power and we can distribute it to every single term. So we have 2 to the 7th times x to the 4th to the 7th all over 5 to the 7th. All right, so we have 2 to the 7th, which would be 128. I have x to the 7th to the 4th. Remember, I have a power raised to a power, so that means we are going to multiply our exponents. So we have x 4 times 7, which would give us 28, all over 5 to the 7th, which would give us 78,125. So we simplified it. But note, we can only use the expanded power rule when there isn't any adding and subtracting, only multiplying and dividing. In the example below, you'll need to write it out twice and distribute. So here we have to simplify 2t plus 3 squared. So because of this plus sign, here we didn't have any adding or subtracting, so it wasn't an issue. Here, because of that plus sign, I have to write it out twice and then distribute. So we have 2t plus 3 times 2t plus 3. So we wrote it out twice. Let me get a highlighter to highlight that. So you have to write it out twice and then distribute. So you wrote it out twice, and now we're going to distribute. So we're going to talk more about distributing in homework 6, but let's kind of talk about it briefly here, because a lot of people know how to distribute. If you want to use the word FOIL, go for it. I don't like the word FOIL because it only works on certain scenarios, and I want something that is mathematically sound that works every single time, no matter what. So I like to just say, let's just distribute. So that means we're going to take our 2t and multiply it by everything on this other expression. So 2t times 2t. 2 times 2 would give us 4. T times t would give us t squared. 2t times positive 3 would give us plus 6t. So notice 2t times everything. Now we're going to do 3 times everything. So positive 3 times 2t would give us plus 6t. And then 3 times positive 3 would give us positive 9. So we did 2 times everything, we did 3 times everything. So now we can combine some like terms. So we have 4t squared. 6t plus 6t would give us positive 12t plus 9. So as far as you can go, these are not like terms, so I cannot go any further. Done. Again, we're going to talk more about multiplying. I guess that would be Module 2 Homework 7. It's either 6 or 7, but in the future we'll talk about this more. I just wanted to kind of bring it up. So whenever you see that plus sign, we have to write it out twice because our exponent was 2. If it was cubed, we write it out 3 times and then distribute. So that's all of our rules. So let's put these rules together and do some examples straight from our homework. So this is what our homework's going to look like. So simplify the following expression completely. 6x to the 7th times 8x to the 10th times 3x squared. So let's combine these together. So combining like terms, let's just multiply our numbers together. So we have 6 times 8 times 3. So in our calculator, 6 times 8 times 3 would give us 144. And then let's combine our let's combine our x's. So if we have x squared times x to the 10th times x squared, x to the 7th times x to the 10th times x squared. Notice we're multiplying, so we can use our product rule. So here we're going to add our exponents. Here we're going to add our exponents. So we have, they're all x's, so they're all like terms. Adding our exponents, 7 plus 10 plus 2, which I think will give us 19, but let's look to see. So 7 plus 10 plus 2, which would give us, yes, indeed, 19. So 144 x to the 19th power. Done. All right, so let's keep rolling. Next page. So simplify completely and then write your answer with positive exponents. Let me zoom this in a little bit. There we go. A little better. So 3x to the negative 3 power cubed times x to the 6th to the negative 3 power all over x to the negative 2 power to the 5th. We got a lot of stuff going on. So here, because there's no adding or subtracting, we could take this exponent and we can distribute it to all terms inside the parentheses. So we have 3 cubed. Don't need the parentheses. So 3 cubed times x to the negative 3 cubed. And then we have next times x to the 6th to the negative 3 power all over x to the negative 2 to the 5th power. I'm just taking little tiny baby steps here. So we just did the 3 going to both of the 3 and the x. So now we have 3 cubed. So 3 times 3 times 3, which would give us 27. So now here we have powers to powers. So we are going to multiply these exponents. So we have 27 times x, negative 3 times positive 3 would give us negative 9, times x, I don't know, I wrote y, sorry, times x, 6 times negative 3, which would give us negative 18, all over x to the negative 2 times positive 5, which would give us x to the negative 10th power. All right, so we're getting closer. Now it says write the answer using positive exponents. There's multiple ways you can do this, but I see that we have negative exponents. Let's go ahead and make those negative exponents positive. Remember, to make exponents positive, we need to flip that term, the individual term, across the fraction bar. So x to the negative 9th, taking that one individually, it's on the top. That means it's going to flip down to the bottom to become positive. Likewise, x to the negative 18th has a negative exponent. It's going to flip down to the bottom to become positive. And lastly, x to the negative 10th is on the bottom. It's going to flip up to the top to become positive. So we make exponents positive by flipping that term across the fraction bar. All right, so that 27, it just is by itself, it's just going to say 27. X to the 10th comes to the top and now becomes positive. X to the negative 9th is going to flip down to the bottom. Whenever it flips across the fraction bar, it's going to become positive 9. X to the negative 18th is going to flip down to the bottom. Whenever it flips across the fraction bar, it's going to become positive. So now we have 27 x to the 10th up top, all over x to the 9th times x to the 18th. So we made everything positive, which is great. Next, now I see, let's combine some like terms. So I see on the bottom we have x to the 9th times x to the 18th. So here, because we are multiplying our exponential terms, we can use the product rule and we can add our exponents. We can add our exponents. They're both x's, so they're like terms. We can combine them together and add our exponents. So going over here, we have 27 x to the 10th up top, all over x to the 9 plus 18. So 9 plus 18 would give us 27. So x to the 27th power. So 27x to the 10th over the 27th power. Getting closer. Now I see that I have x's on the top and the bottom. Get a different color. So let's combine those like terms. Let's combine these exponents. They're both x's, so they're like terms, but combining them together. We are dividing, so that means we can't subtract our exponents. That means we have 27x, and then we have 10 up top minus 27. So that would give us 27x to the 10 minus 27, which would give us negative 17. So 27x to the negative 17th power. Almost done. We have all of our like terms combined, which is awesome, but it says write our answer using positive exponents. So our last step, I'm going to turn that exponent into positive. So in order to make exponents positive, we have to flip them across the fraction bar. So that means it's up top. That means it needs to be flipped across the bottom. Let me use pink because that's going back to make it positive. It's on the top, so that means we need to flip it down to the bottom of the fraction to make it positive. So that 27's just staying by itself, divided by x to the 17th power. Flip down to the bottom, so that exponent became positive. Done. So our answer is 27 divided by x to the 17th power. Pretty intense. There, that looks better. All right, let's do another one. Simplify the expression completely using only one exponent in your answer. So we have negative 2z cubed all over 5 to the 4th power. So here there's no adding or subtracting, so I can take that 4th power and distribute it to every single term. So that means we have negative 2 to the 4th power times z cubed to the 4th power divided by 5 to the 4th power. So negative 2 to the 4th power, notice it's in parentheses. Leave it in parentheses like we talked about on the first page, because that means it's negative 2 times negative 2 times negative 2 times negative 2. So negative 2 4 times negative 2 to the 4th power would give us positive 16. Z to the 3 times 4. So we have a power to a power, so that means we are going to multiply our exponents. We're going to multiply our exponents. So z to the 12th divided by 5 to the 4th, which would give us 625. You always want to simplify your fractions, but there's nothing that 16 and 625 have in common. Our exponents are positive. There's only one exponent, so we're good to go. Our final answer is 16z to the 12th divided by 625. That one seems like nothing compared to this last one. That was a doozy. It was a nice little brain break because look at this one. Don't be scared. All right, simplify the given expression. Q to the 5th y cubed squared times negative q to the 3rd y cubed to the 2nd all over negative q y squared cubed squared all to the 4th. Whew. So there's no adding or subtracting. So let's go ahead and let's distribute these exponents. So we have q to the 5th. I don't know how I did that. Q to the 5th squared times y cubed squared times, let's go ahead, this is negative q to the 3rd. So it's just like saying negative 1 times q to the 3rd y. So let's do the negative 1 separately. So negative 1 squared times q to the 3rd squared times y cubed squared. So everything gets a squared all over. Now everything gets the 4th. So again, the negative 1 to the 4th power times q to the 4th power times y squared to the 4th power times q squared to the 4th power. Okay. I don't know if it looks better or worse, but we're getting closer. So we have powers to powers. That means we are going to multiply our exponents. All right, so in doing so, we have q to the 5th squared. So multiplying our exponents, 5 times 2 would give us q to the 10th times y, 3 times 2 would give us 6 times negative 1 squared. Remember, negative 1 times negative 1, putting this in my calculator exactly like I see it, negative 1 squared would give us positive 1. You don't need to write that positive 1 if you don't want to, but I'm not going to write it so that way it doesn't get confusing. So we know that this was positive 1. Negative 1 times negative 1, which equals positive 1. So I don't need to write that positive 1 because we know it's going to stay the same. Now Q 3 times 2 would give us 6 times y. 3 times 2 would give us 6. So that's up top. On the bottom, -1 to the 4th power. So on our calculator, -1 to the 4th power. So -1 times -1 times -1 times -1, we know would give us +1. Likewise, I know it's going to be +1, so I do not need to write that +1 there. It's fine. So then we have q by itself to the 4th power, so q to the 4th, times y squared to the 4th, so 2 times 4 would give us 8, times q, 2 times 4 would give us 8 again. Getting closer, let's combine some like terms. Let's just look at the top. So if we have q to the 10th times q to the 6th, we are, you can use our product rule because we're multiplying exponential expressions, and that means we can add our exponents. So adding our exponents, let me come down here so we have plenty of room. So we have q, 10 plus 6 would give us 16. Likewise, we have y to the 6th times y to the 6th. Again, we are multiplying two exponential expressions together, so that means we can combine them by adding our exponents. So y to the 6th plus 6, which would give us y to the 12th, all over. Same thing on the bottom. We have, let me use a different color, q to the 4th times q to the 8th. Adding those exponents would give us 4 plus 8 would give us 12. So q to the 12th times y to the 8th. Slowly getting better, slowly getting better. So now let's combine like terms. Let's combine. There's q on top, q on the bottom. I'm trying to see. I don't want to use curly again. I'm going to use this one. So q to the 16th divided by q to the 12th. Likewise, y to the 12th divided by y to the 8th. So those are like terms. I can combine them together. We are dividing, so that means we can subtract our exponents. So subtracting our exponents, we would get q, 16 minus 12 would give us 4. Y to the 12 minus 8 would also give us 4. So I combine all my q's together, combine all my y's together, my exponents are positive, we're done. Q to the 4th times q to the 4th times y to the 4th. I wanted to mention, see how here I put in little like dots or multiplication symbols? I just did it to kind of help spread it out, make it look a little bit neater for me. You don't need to do that, or if you want to do that, it's not any more wrong. Same difference. This is still saying q to the 4th times y to the 4th. Usually we just write them in our final answer. I just kind of use it almost like as spacers to help me. All right, let's do our last one for this page. So it says multiply and simplify completely, including the elimination of all negative exponents. So if we have 2x to the 4th all over 3y to the 5th, all to the 5th power, times 3 to the 4th y to the 8th, all over 2 cubed x to the -10th. All right, so there's no adding or subtracting here, so I can take this 5th power and we can distribute it to every term inside of the parentheses. So we have 2 to the 5th power times x to the 4th to the 5th power divided by 3 to the 5th power times y to the 5th power to the 5th power. And then times second expression, we have 3 to the 4th times y to the 8th all over 2 cubed, but we have x to the -10th. Let's go ahead and bring that -10th up to the top. It's a negative exponent. Let's go ahead and bring it up to the top. Remember, flipping it across the fraction bar will make it positive. So now that x to the 10th will come up top and become a positive exponent. So positive x to the 10th. Flipping it from the bottom to the top will make it a positive exponent. All right, so let's simplify this a little bit. So 2 to the 5th power would give us 32 times x to the 4th to the 5th. Remember, we have a power to a power, so that means we can multiply our exponents. So x to the 4 times 5, which would give us 20, all over 3 to the 5th power, which would give us 243, times 5 to the 5th to the 5th, multiplying our exponents would give us y to the 25th. Now, while we're talking about this, we're multiplying fractions. Remember, multiply top times top, bottom times bottom. So I can move all this into one big fraction, and this stuff will go on the top, this stuff will go on the bottom. So times 3 to the 4th power. So top times top, I'm multiplying these two together, and I'll go up top here. So 3 to the 4th power give us 81, times y to the 8th, times x to the 10th, all over 2 cubed. So 2 to the 3rd power, which would give us 8. Kind of better, I guess. I don't know. We're getting there. Let's combine some like terms. So if we have, let's see, 32 times 81, some big number, which would give us that, 2,592. Let's combine our x's while we're here. So, let's see, if we have x to the 20th times x to the 10th, we are multiplying those two exponential expressions. We can use the product rule. We can add our exponents. Which would give us x to the 20 plus 10, which would give us 30, times y to the 8th. So we simplified everything up top. Let's look at the bottom. On the bottom, we have 243 times 8, which would give us 1,944. So 1944 times y to the 25th, getting closer. All right, so let's combine some like terms. First of all, we have a fraction. Talking about combining like terms, we have just numbers that we can combine together. So we can combine 2592 and then 1944. So we have a calculator. Let's use our calculator because sometimes our calculator will help us. It will simplify fractions for us. Let me show you how. So if we have 2592 divided by 1944 equals some ugly decimal. I don't want it in decimal form. I want it in fraction form. But notice up here, above my PRB button, it says F to D, and the arrows go both ways. So that means fraction to decimal or vice versa. It can go from a decimal to a fraction. So notice it's in light blue. So I need to hit my second light blue button first. Notice it'll say second down here. Oh, there we go. That's better. So second button first, and then my PRB button to say, okay, take that decimal and then turn it into a fraction. So equals 1 1/3. Again, we don't want mixed numbers. We want improper fractions. So if you look at the button right below the PRB button, it takes mixed numbers and it turns it into improper fractions. So if we do second and then hitting this ABC button equals, boom, 4/3. So we know this will simplify down to 4/3. In other words, they both have 648 in common. I would have never known that. So they divided out 648 from the top and the bottom to simplify that fraction. But let me do it one more time to show you in your calculator. What you can do is put the fraction in 2592 divided by 1944 equals, turn it into a fraction by second, this PRB button, because above it says fraction and decimal, press enter, and then do second, and then hitting this A, B, and C button right underneath will turn the improper fraction, turn the mixed number into improper fraction, which gives us 4/3. If you need to back it up, rewind it, slow it down, you do you. So 4/3 we know simplifies that. So 4 is up top, 3 is on the bottom. Then that x to the 30th power is up top, it's going to stay up top. Then we have our y's. Color. What I'll do next. So for our y's, I have y to the 8th divided by y to the 25th. We are dividing, so that means we can subtract their exponents. So if we have 8 minus 25, that would give us y to the negative 17th power. So because it's negative, I know it needs to go down here. So y to now the positive 17th power. We combine all of our like terms, our exponents are positive, we're done. Let me write this down here. So if we have y to the 8 minus 25, that would give us y to the negative 17th power. And then we're going to say it goes on the bottom to make our exponent positive. So it goes on the bottom. Since y to the 17th power, usually that would go up top, but it's negative, so go ahead and flip it down to the bottom to make it positive. So because it's negative, it's going to go down to the bottom. All right. Next page. Last two like this. Simplify completely. 2k to the 4th all over k cubed r squared, all to the negative 3 power. There's no adding or subtracting. So I can go ahead and distribute that negative 3rd power. So we have 2 to the negative 3 power times k to the 4 to the negative 3 power all over k cubed to the negative 3 power times r squared to the negative 3 power. All right. Let's go ahead and we have powers to power, so let's go ahead and multiply those exponents. I don't want to do too many things at once and get messed up. So I'm just going to leave that 2 to the negative 3 power as is for 1 second. So 2 to the negative 3 power times k. Multiply our exponents. 4 times negative 3 is negative 12 all over k. 3 times negative 3 is negative 9 times r. 2 times negative 3 is negative 6. All right, so now let's make everything positive. So we know it flips across the fraction bar to become positive. So this 2 to the negative 3rd power is going to go down to the bottom to become positive. This k to the negative 12th power is going to go down to the bottom to become positive. This k to the negative 9th power is on the bottom already, so it's going to go to the top to become positive. This r to the negative 6th power is going to go up to the top to become positive. So we're just flipping it. If it's on the top, it goes down to the bottom to become positive. If it's on the bottom, it flips up to the top to become positive. All right, so that 2 to the 3rd power is going to go to the bottom, become positive, times k to the 12th, going to the bottom, becoming positive. This k to the 9th is going to the top to become positive. And then this r to the 6th is going to the top to become positive. Getting closer. All right, so now let's combine like terms. If we have k to the 9th divided by k to the 12th. We can, we're dividing, so we can subtract those exponents. So if we have k to the 9 minus 12, we would have k to the 9 minus 12 would give us -3. So because it's negative, so it goes to the bottom. You know, it's negative exponent. So it goes to the bottom, and that'll make it positive. Goes to the bottom, and that'll make it positive. So, which makes sense because if we go back, we were write out 9k's up top, 12k's on the bottom, we canceled them out. That means 3k's are left over on the bottom. There's more on the bottom than there are the top. So that kind of makes sense. Not kind of, it should make sense. R to the 6th divided by, is up top, it's going to stay up top. That 2 cubed, so 2 times 2 times 2 should give us 8 on the bottom. And then we have 9 minus 12, we said was r to the -3. I'm sorry, k to the -3. Because it's negative, it's going to go to the bottom, and going to the bottom makes it positive. So we have r to the 6 all over 8k cubed. All of our like terms are combined together. All of our exponents are positive. We're done. One more like this. Simplify the following expression completely. Write your answer only using positive exponents always. So a cubed b to the -1 all over a to the -1 b cubed all to the -3. All right, let's go ahead, and there's no adding or subtracting, so let's go ahead and distribute that exponent. You can go in multiple different orders, but let's just go ahead and get rid of that -3 outside. So we have a cubed to the -3 power times b to the -1 to the -3 power all over a to the -1 to the -3 power times b cubed to the -3 power. Remember, power to a power, so that means we are going to multiply our exponents. So we have a to the 3 times -3, which is -9, times b, -1 times -3 is +3, all over a, -1 times -3 is +3, times b, 3 times -3, which is -9. All right, so let's go ahead and make these exponents positive. So let's flip. So this a to the -9th is up top. It's going to flip across the fraction bar, meaning it's going to go to the bottom and become positive. B cubed's already positive, so it's staying there. A cubed on the bottom is positive, so it's staying there. B to the -9th, it's negative, so that means it's going to flip across the fraction bar, meaning it's going to go to the top of the fraction to become positive. So now up top, we have this b to the 9th became positive, so it flipped across the fraction bar, times b cubed is up top, it's going to stay up top. On the bottom, we have a to the 9th flipped across the fraction bar, so that exponent became positive, times a cubed. On the bottom, it's going to stay on the bottom, nothing's going on to it. Here we go. So now let's combine some like terms. We can combine our b's, combine our a's. They are being multiplied, so that means we can use our product rule. We can add our exponents. So we have b up top. Adding our exponents, 9 plus 3 would give us 12. On the bottom, a, 9 plus 3 would also give us 12. All of our like terms are combined. Our exponents are positive. Final answer, e to the 12th divided by a to the 12th. All right, our last thing for this section is talking about scientific and standard notation. So scientific versus decimal notation. So examples of numbers in decimal or standard notation is what we're used to. So we can have something like this, like 1,200,000, 500,000, or this crazy big number, right? These are just numbers written out. All of these zeros make it, for one, take up a lot of page, and it makes it confusing because you have to count all these, all this good stuff. We can write these same numbers in scientific notation. Scientific notation is great because it's a more condensed form. It's easier to see because you can see how many zeros you have by using the exponents. And in our calculator, there's only so much room to write this stuff. So it would take up too much room in our calculator to write that whole answer. So our answer will be in scientific notation on the calculator. So this is the same number in scientific notation and then the same number in decimal notation or standard notation. So same numbers. So 1.2 times 10 to the 6th, 5 times 10 to the 5th, or 1 times 10 to the 22nd power. Knowing me, I would have messed up and like miscounted all those zeros or something. So notice, for scientific notation, there is a template. There's like a standard form. So we have A, which A is some number between 1 and 10. Notice it's only one digit, so it's really going to be like 1 point something, because it could be decimals, but 1 point something, let's go like this, all the way to 9 point something. So 10's not included, going back to our interval notation. So it could be 1, it just can't be 10. It could be infinitely close to 10, 9.99999, just not 10. I want one digit to the left of the decimal. One digit to the left of the decimal. And notice it's always times 10. 10 tells us how many times to move the decimal, and then the R will tell us actually the number of times how many to move the decimal. The 10 will tell us our zeros. So writing our answer in scientific notation, move the decimal until you have a single digit to the left of the decimal, and the exponent R is a number of times that you move that decimal place. Next page. So note, if you have a negative exponent, that means you're going to have a really small number. That means move your decimal to the right. If you have a positive exponent, that means you're going to have a really big number. Move the decimal to the left. So instead of going left and right, think, okay, you're negative. So that means a really small number. If you have a positive, that means a really big number. Because sometimes left and right will be flipped based off of which way you're going. Let me show you. Let's do an example. So write the following number in scientific notation. So we have 730,000. So our decimal's at the very end. I want to take this decimal and I want to move it until I have one digit to the left of the decimal. So moving it 1, 2, 3, 4, 5 times. So I'm left over with 7.3. I don't need all those zeros at the end. I'm left over with 7.3. Notice there's one digit, just 7, in front of the decimal. Times 10, it's always times 10. And then my exponent is the number of times I move the decimal. So I move the decimal 5 times, so my exponent is 5. Notice it's a big number, so I had a positive exponent. So my answer is 7.3 times 10 to the 5th. Likewise, down here, I have 0.000000104. So taking my decimal, I move it 1, 2, 3, 4, 5, 6 times. So we did 6 times. I'm left over with 1.04. Notice 0 is not a digit. So 1, I have one digit to the left of the decimal, so I don't need all those extra zeros. So 1.04 times 10, that's our template. And I move my decimal 6 times, so to the 6th power. But notice, this is a really small number. So I'm going to have a negative exponent. Small number, so negative exponent. So that 6 is going to be negative. So my answer is 1.04 times 10 to the negative 6th exponent. Okay, so going down here, write the following numbers in decimal notation. So 5.6 times 10 to the negative 7th. So notice it's a negative exponent, so it's going to be a small number. Negative exponent. So small number. So remove the decimal to the left. So 5.6, moving the decimal 7 times to the left for the small number. So 1, 2, 3, 4, 5, 6, 7. So here's my new decimal. I'm going to fill in all of these little gaps with zeros. So 1, 2, 3, 4, 5, 6 zeros. So my answer is going to be 0.123456 zeros and then 5, 6. 1, 2, 3, 4, 5, 6 zeros. 1, 2, 3, 4, 5, 6 zeros. So 0.00000. I think I messed up, but you know what I mean. 0.00000056. There we go. All right, let's do another one. 3.4 times 10 to the 8th. Notice this is a positive exponent. So I'm going to have a big number. So that means I'm going to move my decimal to the right. All right, so 3.4, moving the decimal 8 times to the right. So 1, 2, 3, 4, 5, 6, 7, 8. There's my new decimal. So filling in the gaps with zeros. So 1, 2, 3, 4, 5, 6, 7 zeros. So we have 3, 4, and then 1, 2, 3, 4, 5, 6, 7 zeros. Don't use a comma in your answer, and I'll tell you that on the homework, but just put it just like that, no commas. No commas, just leave it just like that. Perfect. All right, so this is super helpful, but it's also more helpful to be able to do computation. So multiplying these really big or really small numbers, or dividing these really big and small numbers. Our calculators are amazing, but they can't do every computation. So with scientific notation, we can actually perform calculations with really, really big or really, really small numbers. So, for example, multiply the following and express your answer in the appropriate scientific notation. The question's in scientific notation, so the answer needs to be in scientific notation. 1.4 times 10 to the negative 37th power times 3.6 times 10 to the 34th power. So it's kind of like combining like terms a little bit here. We're going to do 1.4 times 3.6. So 1.4 times 3.6, and that would give us 5.04. Remember I got that, but we did 1.4 times 3.6. And then times 10, because that's our template. And we're going to combine like terms. Great, I just got that number all over me. We have 10 to the negative 37 times 10 to the 34th. These are like terms. We can multiply these like terms together by adding the exponents using the product rule that we just talked about. So both base 10 combine into the same base 10, adding our exponents, negative 37 plus 34, which would give us 10 to the negative third power. Negative 37 plus 34, which would give us negative 3. So 10 to the negative third power. So 10, negative 3. Done. So 5.04 times 10 to the negative 3. Same thing with dividing. If we have to divide 9.1 times 10 squared all over 4.7 times 10 to the 5th, combining like terms, let's do 9.1 divided by 4.7. And we get that crazy number, 1.93617, blah, blah, blah. Let's round it to 2 decimal places. It'll tell you in the homework. So let's round it to 2 numbers after the decimal. So let's round this 3. Looking next door is a 6. Remember, 5 or higher, it rounds up. Anything less than 5, it stays the same. So looking next door is a 6, which is higher than 5. So this is going to round up. So 1.93 is going to round up to 1.94 times 10. And then let's combine our 10s together. We have 10 squared divided by 10 to the 5th. This time we are dividing exponential expressions. So remember, you can subtract your exponents. And this is what kind of gets confusing. So we have 10 squared divided by 10 to the 5th. So 10 to the 2 minus 5, which would give us 1.94 times 10 to the negative third power. And I say it's confusing. It's okay to have a negative exponent here because here we're talking about moving the decimal left or right. So this will tell us move our decimal 3 times to the left. So our final answer is 1.94 times 10 to the negative third power. All right, so one last page just to talk about real quick. We talked about a lot of different properties on this section. So I just created a little table putting it all together for you. So let's talk about it. Properties of exponents. Multiplying and dividing exponential expressions is where you're going to add or subtract exponents. So for example, 2 cubed times 2 to the 5th. You're going to add it and give us 2 to the 8th. If we have 2 to the 12th divided by 2 cubed, you're going to subtract those exponents and get 2 to the 9th. If we have an exponent raised to an exponent, we're going to multiply those exponents. So x to the 6th to the negative 2 power. Multiplying those exponents would give us x to the negative 12. It's negative, so it goes to the bottom. Zero exponent. Anything raised to the 0 power is 1. So 2 to the 0 is 1. Negative exponents. To make a negative exponent positive, move it across the division line or across the fraction bar. So if it's from the top, move it to the bottom. If it's on the bottom, move it to the top. For example, 2 to the negative 1 power would be flipping it to the bottom. So it became 1 over 2 to the first power. 2 to the first power is just 2. So this will give us 1/2. If it's on the bottom already, it's going to move to the top to become positive. So 1 over 2 to the negative 1 power is going to move to the top. So 2 to the positive 1 power over 1. So there's nothing there anymore. So 2 to the first power divided by 1 is just 2 to the first power. 2 to the first power is just 2. So kind of what the property is, what you do, and then some examples. We also talked about scientific notation. Scientific notation is the template A, which A is between 1 and 9. It says 10. So 1 point something and 9 point something. And then times 10 to the rth power, the rth power. R is the number that we are moving our decimal to. If it's a negative exponent, it means a really small number. If it's a positive exponent, it means a really big number. So always check your final answer. That's in scientific notation, which means 1 digit to the left of the decimal. So 1 number and then point whatever. So that is all of Module 2 Homework 5. You can now work on your Module 2 Homework 5 assignment. If you have any questions, please let me know. Let one of our tutors know. If not, thank you very much for watching. Have a good one.